some delay. So.
Yes. So this is a test. Oh, this is too loud. Can you hear me on YouTube too? Okay, I think then we can get started. Okay, let's see. Okay, is everything good? Can you hear me online? It's good, right? Okay, so welcome everyone. Welcome to the seminar in computer architecture. So this course is created and is led by Professor Onur Mutlu. Today I'm doing this lecture, which is more of an introductory lecture into the logistics and purpose of this course. We're going to briefly describe a little bit also the research topics that are looked into by Professor Mutlu's research group Safari, and also explain a little bit about the philosophy behind the group and its works. So first of all, a brief self-introduction. So I'm a co-instructor in this course. There are two co-instructors. My name is Konstantina, and I'm helping Professor Onur Mutlu with the teaching. I'm a senior researcher and a lecturer here at Safari Research Group. I have finished my PhD in National Technical University of Athens. And my research areas where I'm interested are hardware software co-design, heterogeneous system architectures, hardware acceleration, and in general, also creating optimal and efficient architectures for bioinformatics. Now let's see more information about the lead instructor of this course, which is Professor Onur Mutlu. So Professor Mutlu is a full professor here at ETH since 2015. Previously, he was a professor in Carnegie Mellon University. And before that, he started the computer research architecture research group in Microsoft Research. During his career, he has worked at different places. You can see here that he was affiliated with Google, VMware, Microsoft, Intel, AMD, and very recently, he also did a sabbatical in Stanford University. So a while back, when he was still a student, maybe some people view, he did his PhD in computer engineering from University of Texas and his bachelor in computer engineering as well as psychology from University of Michigan. So his research interest and his teaching focuses on a very broad area of topics, but some more important pillars that we can discuss here are computer architecture, systems, hardware security, and bioinformatics. So next, let's go to our next instructor, Mohammed. Mohammed is sitting on the top of this class. He's a senior researcher and lecturer here at Safari, and he has gotten his bachelor, master, and PhD degrees from the top university in technology, Sharif University in Iran. So he's also working in research and teaching in various areas that Safari is also very active, like computer architecture, memory and storage systems, near data processing, heterogeneous system architecture, bioinformatics, as well as interconnects. This is a picture of a Safari research group. This is a picture from 2020. So some of these members actually right now are not in Safari, but have moved on to other faculty positions or industry. But some of them are still in our group. And the big chunk of the TAs are currently here in this row. I think most of them are here. You can meet them during the classes, and you can also look them up online. This is a list of students that have gotten their PhD with Professor Mutlu, as well as done their postdoc here. So feel free to look them up online, and also in general, look up all the material that we upload here in Safari, where you can see very interesting conversations, scientific presentations from conferences, and a lot of learning materials. This is a talk from Professor Mutlu, how to apply to grad school and do some impact research. So now let's go a little bit to discuss the current mission of Safari Research Group, which is also very much, let's say, integrated in the scope and the goal of this seminar lesson. So the goal is to enable fundamentally better computers. And we want in this course to get you acquainted with different papers and research that is done that enables and creates different perspectives and different ways to design better systems and better computers. So towards this goal, we're going to propose and suggest and study all together papers that cover a broad range of topics. For example, we're going to discuss processing in memory architectures, accelerators that are heterogeneous, and heterogeneous processors that focus on specific applications that need some sort of more energy efficient execution and performance optimized execution. These are domains like machine learning, vision, genomics, and some other biological signal processing. And we will also delve into topics like storage, sensors, memory, and interconnects. Now, Safari does a lot of, let's say, varied research. Here you can see some main directions that we follow, and we're very active. So first of all, we work towards the important problem of building fundamentally robust architectures in terms of security, reliability, as well as safety. We also work on delivering energy efficient architectures. For example, this is very relevant nowadays if we take into account all the energy hungry systems that are built nowadays for AI. And we can implement those by using and mitigating towards more memory-centric and data-centric architectures. Next, we also tackle problems like working with latency and predictability, and creating fundamentally intelligent and evolving architectures, for example, some data-driven or data-aware architectures. And not only that, but also we're focusing with the motivation of some very important domains such as machine learning, genomics, medicine, and health. We are looking into creating architectures that are mostly suitable and equipped to deal efficiently with these topics and problems in these domains. So traditionally, if we look into a computer architecture, it is usually considered as the interface between software and hardware and the underlying microarchitecture that implements this interface. However, here we're going to adopt a much broader topic that is also adopted recently in both research as well as industry, because it can actually bring the most beneficial and most impactful results. So we're going to see and work on papers that cover topics from algorithm up to the level of design, and we're going to be to promote the idea that we have to co-design all these different aspects in order to have a system that is the most efficient in terms of energy consumption as well as performance and other aspects. And we highlight the fact that it is very important to do this co-design, because focusing on only one of those aspects can only get us as far, not very far. So, for example, we could have an algorithm and we can optimize and customize the underlying hardware with extra logic to make sure that this is optimally executed. So therefore, across all this course, you're going to see papers that really promote the co-design across this hierarchy from algorithms to devices. And we specialize as much as possible depending on the design goals we have each time. So this is a very research-oriented course, but it also really wants to stress the importance of the teaching. And as Professor Mutlu often says during his lectures, teaching and research is like the two sides of the same coin. And each feeds the other. So for example, when we're doing some research, there's usually a long time of looking into something and trying to figure a way to solve problems. And finally, we reach some conclusions and some results. And what we want to do with these results is then to report them and communicate them back to the community. So eventually, they become more like a learning material, and they even end up to be some fundamentals that we teach the next generations. So then we teach this stuff to students. And while teaching and brainstorming and discussing and delving deeper into the architectures, what happens is that often we come up with new ideas, and this therefore promotes even more ideas and directions for new research. So it is like a virtuous cycle, and we really want to make sure that during this class you understand this procedure, and this is how all this class is structured. So for that reason, we have the material from Safari research group online, so you can see a lot of material about the courses that we offer, about all previous years. And we make sure that we open source most of our works, as it is very important for high impactful research. And in order to quickly have new developments and ideas on top of the ones that we already published, you can find them all online. They're open source, and you can experiment with them and come up with your own maybe solutions upon them. Here are the major links that you will see also on our course pages, that you can see them throughout the semester and in general during your studies. So then let's move on and go to over some basic principles that Professor Mutlu always wants to instill in his students and in the people that are interested in computer architecture. So we already covered the importance of teaching and research and how one feeds into the other. The other important aspect of Safari's, Professor Mutlu's philosophy And the goal of this class is that you get to focus on insights on the papers that you're going to be assigned to read and study, and also the ones that your colleagues study. So you need to focus on the insights and focus on reading the papers with a critical eye. This means that you are able to identify the key contributions of each problem, of each paper, and also finding the weaknesses, finding ways to do the same, let's say, implementation in a different way, in a more efficient way. And you have to be very open-minded about it. You have to be able to identify the contribution of the paper, and this contribution could be even the fact that they identify a new problem, or if a problem already exists and it is known, they're proposing a new way to tackle this problem. So it could be really anything, and you have to have a sharp eye to identify it and understand it. Then, of course, we're going to focus a lot on learning and scholarship. This is achieved as you're going to have to study very hard on the papers that you're assigned to, and to understand them, you have to be very detailed and also go into the literature and study other papers to understand. So in that sense, we're also promoting a lot of learning and studying across state-of-the-art works to understand exactly what is the contribution and the key mechanism of a paper, for example. What is also very important for us is that we create an environment where we can openly discuss new ideas. We can brainstorm together, collaborate, come up with new ideas on the papers, not be afraid to pinpoint weaknesses in the papers and suggest new ways to make things better. And this is going to be implemented during this course, as we want to keep all our classes very active. So this means that each time a presenter is going to get assigned a paper and you're going to present it. This is the paper assigned to you. But this is not something that we want only to observe, but we want the audience to engage in the conversation. So it's ideal that people in the audience have read also the paper offline, and then you come here and you all discuss together, also suggest any weaknesses that you have identified, any ideas that you come up with during the discussion. So we want it to be a very creative and insightful procedure for all of you. So overall, as this class is very much oriented towards doing good research and impactful research, the quality of your work is definitely going to impact you, to define the impact. So what Professor Mutlu suggested for you to do in general is follow your passion. This means that if you have an idea and you really believe in it, you have to push hard, and potentially you will have to encounter some people that, for example, don't really encourage you. And this is the case for many papers that when they were first published, they were very much critically acclaimed, and the reviewers were not really believing in them. They had to go through multiple rounds of reviews to get accepted in some conference or journals. However, they made it, and they even have become now some of the fundamental aspects of computer architecture. A typical example of this is out-of-order execution, which was really questioned, but nowadays it has been adopted in most systems. Of course, it has been, let's say, evolved, and it has been improved. But in the beginning, the ones that proposed it actually came across resistance. However, it's very important, as we have said so far a lot of times, to develop your own ideas. But it's also very important to not neglect the fact that in order to implement your ideas, sometimes you're gonna have to create the infrastructure to enable the implementation of the ideas. So it's going to be a synergy of these things, of building infrastructures and building then ideas and new systems on top of them. This is going to enable basically some bigger and more impactful work on your side. So our advice is to work hard, to enable your passion, be resilient, and don't give up. Stay focused on your target. Focus on learning a lot and reading a lot about literature and state-of-the-art works. Make sure your work has really high quality, and this will lead to a good, impactful research. This is very important, and we have here some more material for you to read in the terms of how to make sure that the research that you conduct is impactful. So this is a talk from Onur Mutlu that shows how to apply to grad school and how to do some impactful research. So be sure to take a look at this one. And usually he also suggests students to take a look at this transcript. This is a transcript of Richard Hamming's interview, where he explains how basically you can do your research the most impactful. So every researcher has some weaknesses and some assets, let's say. It's very important in order to make sure that you are like top tier research and do a really high impactful research, is to acknowledge even your drawbacks and make sure you find a way to turn them potentially into new assets and advantages for you. And this transcript is very interesting because Hamming also provides some experience from his own life. So he, for example, he stresses the fact that he himself has some egotism issues. So he learns how to, let's say, leverage this in order to facilitate him to become a very strong researcher. And then he goes on to more important topics on how to actually make research that is impactful. For example, it's also a matter of choosing to work on important problems. So if you don't work on important problems, your research is by default not going to have a great impact on the world. Also, you have to get emotionally involved and invested. So if you're, let's say, your heart is not very much into it, maybe this will hold you back and hold back from achieving great results with your research. So basically, you can take a look at this. It's a very interesting read. So go ahead, please, and whenever you have time during the semester, read it and maybe get inspired to also try to work like this during the semester on your papers that get assigned to you. So now let's go on and talk about the role of this course in the scope of computer architecture. So computer architecture is the science and art of designing computing platforms. And as we said before, we're going to take a broader perspective on this topic, and then we're going to include papers and information and educational material about the hardware, the interfaces, system software, and programming models. It's important to keep in mind that every time we have a different computing platform, it is designed with some specific goals in mind. So for example, sometimes the goal is to create a platform that achieves the highest performance on some specific workloads. Other times, the important thing to do is to create a mobile device that can also be portable. And in that case, you want to optimize the longevity and battery life. Sometimes you just need a general purpose device that is able to have a good performance across different workloads. So in that case, you have to have some average performance across different applications and workloads. So there are many more examples to show that. A very striking example is that you have to think of how much different the design goals and requirements are when designing a supercomputer rather than a smartphone. So although some fundamental principles are the same, the design goals are different. So you have to, in its case, make different design decisions. So now we're going to skim through some examples of such platforms to just understand the variety and the very broad options that there are. So here we can see a mobile device, a drone. This specific picture shows a device that needs to do DNA sequencing, but it needs to happen, for example, in the space. So it has some very specific requirements. Self-driving cars, machine learning accelerators, data centers, supercomputers, TPUs, and of course, the very popular GPUs. But even here in GPUs, there are a lot of aspects to consider. They're a very popular device as they are mostly known for the computational capabilities, but we should also keep in mind that they have access to high bandwidth memory. And as new generations of GPUs come and they get evolved, you also have to evolve the interconnects. And you have to create these NVLinks to make sure that you have as fast and as broad access to high bandwidth memory as possible. You can see that this is driven by real needs, where here AI models are growing exponentially as time goes by. This means that the GPUs need to really scale in order to address the higher workloads. And they definitely need these high interconnect and NVLinks to be more efficient. This is another example of ML accelerator chips. And then we move on to some more novel architectures. Here we're going to see some examples of processing in memory architectures. So typically what you've been taught so far is that we keep the computation separate and away from the memory. However, there is a new trend where we create memory chips that are also equipped with doing computation. And this is an example of this case. This is the chip created by AppMem company, but there are other more examples. For example, here Samsung has created with a 3D stacking technology an example of stacking and placing memory dies on top of logic so that we can make the computation happen very near to the memory. In this case, they do that so that they can efficiently operate and execute multiplication tasks. But of course, now as things progress, you can see many different and more complex operations. Another example is SK Hynix or Alibaba. And we can also see that there are even optimized interconnects and ways to facilitate the communication and offloading of computation from the CPU to the memory. So after discussing this, why study computer architecture? The main goal is to enable better systems. We need to make computers faster, cheaper, smaller, and more reliable. And to do that, we have to take advantage of the underlying technology and circuits. So any breakthroughs in technology can also motivate us to create better systems and then to employ like basic concepts of computer architecture and also push past them. We're also able to enable new applications and systems. If you take a look back, we can see, for example, that up until recently, virtual reality, self-driving cars, or some personalized devices for genomics were not possible. So the need to have these applications can also drive architecture changes and vice versa. In general, we're able to find better solutions to problems. For example, all these software innovations that keep happening are built on trends and changes in computer architecture. So as you can see, by studying computer architecture, you get to understand in depth why computers work the way they do and come up with new ways to work and apply changes to have impact on different domains and fields. Specifically today, it's very exciting to work on computer architecture as there is a large paradigm shift. We need to come up with novel architectures in order to address complex problems of our time. So what we have to keep in mind is that there are difficult problems nowadays that drive changes in computer architecture, but also problems that are caused by shifts in computer architecture. So there are so many different aspects that we have to take into account. It's a very complex design space, and there are no easy answers and choices when you're designing a system. So you cannot have definitive answers to these problems, and you have to think how to combine them, how each one can have an adverse maybe impact on the other one. So you have to think synergistically and have some trade-offs to make a design choice and create different systems. So all these are very exciting and can motivate us to work on computer architecture. So now let's go into some more practical details on this course. So in this seminar, we're going to cover some fundamental and cutting-edge research papers in computer architecture. So this is what you're going to gain out of this course. First, you're going to develop some technical skills. This is going to happen by delving and studying more into the papers. So you're going to learn a lot about how different architectures are being done. Potentially, you could even reproduce them yourself. We are also going to promote a lot of critical thinking and analysis. This is going to be very encouraged when you do the reviews of the papers. We want you to approach them with a critical mind so that you are able to identify both their strengths as well as their weaknesses. And then you're going to develop some very important skill that maybe so far some of you have not yet given the opportunity to do. You're going to be asked to give a technical presentation of different concepts of papers. This means presenting a paper in front of your colleagues. Maybe some of you have not done a presentation yet, and it's a great opportunity to develop this skill for yourselves too. But also you're going to be asked to have this sort of technical presentation in written form as well. So you're going to be able to learn how to also do some sort of critiques and put them on the paper and submit them. And of course, out of looking into different papers, because in the end, we're going to have like 20 people presenting papers, you're going to be able to come to get acquainted with different hot areas and research directions of nowadays, and you're going to be maybe motivated to work on them yourselves. So the major goal of this class, and also the major thing that you're going to have to do, is to analyze, present, and discuss papers and ideas in computer architecture. So how this is going to be implemented, both for the presenter and the people that are participating in a presentation. So the presenter needs to read very carefully the paper, potentially expand to also other prior works to state-of-the-art works, so that they're able to understand the problems that its paper addresses and better understand the solutions to. When you have been able to fully absorb this information, you will be in a position to critically analyze this paper and think and synthesize across everything that you've read to understand what are the strengths, what has it contributed to the field, but also what kind of weaknesses it had. And then you're called to prepare a clear and rigorous talk to present to your colleagues, present it as best as possible, answer questions. For example, you have to understand the paper so well that you're able to answer your colleagues' questions if they don't understand something during your presentation. And finally, overall, analyze and synthesize both across your preparation as well as during the presentation and even after. Afterwards, because you're going to also each other provide feedback to other people that are presenting. So the same goes for the participants. You will do, of course, the above when you're presenting yourself, but when you're here to attend the presentation of one of your other colleagues, you're going to have to engage into the conversation, discuss actively, ask questions that you don't understand, or speak up your mind when you have new ideas or you identify any, let's say, other weaknesses and room to improve the paper. These are some of the topics that the papers are going to cover, but it's not an exhaustive list. What's going to happen is that we're going to present to you, we're going to upload it someplace, a list of papers that cover a broad area of topics, and you're going to have to look into them and rank them in terms of your preference. And then we're going to evaluate your preferences and make a nice assignment so that we can include a different variety and a good variety of different topics, but also as close as possible to your own preferences for you to present. So this is a recap of what we achieved during this course. And then it's very important here, we have discussed this virtuous cycle. And I think this schematic really shows how it works and how it's going to implement it during this course. So what we have here is that you're going to start by reading and making sure that you do a good critique of the papers, understanding the problems. And once you understand them, then you're in a position to start questioning them if what they did is important. You might even think that the problem they tackle is not that important. You're in a position to brainstorm with each other to find better solutions than the authors actually recommend. And through the brainstorming and the interaction amongst you, you're going to potentially develop some new out-of-the-box ideas. This is the ideal path. Sometimes this path fails and you have to come up with new ideas. It's not easy to pinpoint the gaps and the shortcomings of the literature, but sometimes you can be also lucky and find a good idea pretty quickly. And once you have a promising idea, then you get to do the implementation. Again, there should be collaboration among scientists and engineers working hard. And once you get some promising results, then you are in a position to start writing your own paper and publishing so that others can be educated and then build upon it and continue in this manner, even again yourself, or you can just provide this feedback to other researchers. So hopefully this is going to be what is going to happen to you also in this semester. Ideally, you could even develop an idea based on the paper you study, and you'll be motivated to work on it maybe at some later time. So now let's go into the logistics. We've been through the instructors and the co-instructors. This is a list of everyone that's going to be teaching assistants and mentors. Some of them are here, but not all of them. You can also look them up online and look at what they're working on. These people are going to be your mentors, which means that each one of you is going to be assigned a paper to present, and you are going to have to get in touch with your assigned mentor so that they can guide you into the process of understanding the paper and create a good presentation so that we can have a creative and fruitful discussion here all together during the presentation sessions. So some more specifics and prerequisites for the course. The attendance is required for all of our meetings. Ideally, you will join in person. Of course, we also have a Zoom link that you can use. And please, if you plan for some reason to not attend at all, let us know and get in touch with the instructors if you need to notify us of such a case. Each one of you is going to present one paper. So you're going to prepare by collaborating with your mentor, and you're going to be asked to deliver a full presentation that's going to be structured in the sense of presenting the paper, accepting questions from the audience, and then leading a discussion where we will brainstorm all together about the other weaknesses and other ways to improve upon the work. Non-presenters are going to be asked to participate, so you should make sure that you pay attention. Even beforehand, you should skim through and read the paper that is going to be presented that day so that you are able to contribute to the conversation with your own critique and your own take and what you understood and what you could do differently. After each presentation, the non-presenters are going to take a short quiz online. This is going to be uploaded on Moodle, and it's going to be multiple choice questions. They're going to be live for one full day, and you're going to answer questions that are based on the paper that has been presented. So make sure you have been paying attention. You will also provide comments on the presentations and feedback for the presenter after each presentation. And lastly, once the course is completed, each one of you is going to write a synthesis report. In this one, we're going to answer questions about the papers that we've seen so far across all the semester, what you liked best, some critique again, and some additional questions about your take on research. This is the course website. It's already online. You can find all materials there. For example, all the slides are going to be uploaded there, some announcements, the papers are going to be uploaded here. But you will also heavily work on and use Moodle. On Moodle, you can find all announcements, all due dates. You will have the quizzes there. You will provide your feedback on the presenters, and you're going to submit all of your assignments. There should be also potentially a forum where you will be able to ask questions, but you also always are welcome to reach out to your mentors and the TAs in general if you have some questions. Now let's go on with the first deliverables. So we have homework 0. This is not exactly homework in the typical sense. You're just providing us with some student information about your background and what you want to do. So today it's the 18th. This is going to be due on September 25. Please make sure you do this, because if you do not submit this on time, then we will not be able to schedule you for your presentation. And basically it's going to be like you are quitting the course. And it's very important at this point to stress, but I will also repeat myself later. So we really need you to be committed in this course. We have already many people that are registered, and there is a long waiting list. So if you're not sure this course is the one for you, you don't want to take the time to do all the assignments and be engaging in the conversation, then maybe this is not the course for you. And if that's the case, you should leave it so that someone else from the waiting list can actually register and benefit as much as possible. It would also make it much easier for us if you communicate this in time to us so that we have a very good organization of the presentations. Next assignment is analyzing a paper. This is going to have a deadline of 2 weeks. You will get to review and write a critical analysis of a paper. This is also mandatory to pass the course. Then we're going to, very soon, next week, ideally, we're going to decide on the paper preferences. So we will upload the potential papers for you to present as soon as possible. You will be called to rank them in the Moodle. And then we're going to make, again, the assignments based on your preferences, but also some criteria we have about covering different areas and giving a holistic view of today's trends in computer architecture. So please, again, be very mindful and do all these things on time so that we can schedule everyone nicely. It's very important that you all have adequate time to prepare. And this is why we have to do the assignments next week so that you all have at least 2 weeks to prepare for your talks. And finally, the synthesis report. This is something that is done once at the end of the semester, usually after a month of the last presentation. You will answer some questions about everything that you have read and have presented or saw being presented to and listened to during the course. And this is also very mandatory, and I will show you the exact grading rubric later on. Okay. So now that we saw pretty much what is asked for you during this course, do you have any questions right now? Any questions on how the course is conducted? What is asked of you? Okay, so if not, we can then go on giving you some advice on how to deliver a good talk, because this is going to be basically 50% of your grade for this course. So this is an overview of how you get to do the critique of a paper. Okay, of course, you keep in mind of the title, the topic, the authors, and the venue. So you have to have in mind where does this paper, who does this paper address, okay? Then you should be in a position to make a good summary to communicate to other people, which means that you have to clearly identify which problem the paper is trying to solve, what are the key ideas and any key insights, what are the key mechanisms that are proposed, what is the implementation, and what are the key results. Once you have presented this, you can move on to presenting the strengths, the most important ones, of course, because these potentially are some endless list, but you get to identify the strengths in the sense of, is it an important problem? Does the paper solve the problem well enough? Is it well written? Stuff like that. And then move on to identifying the weaknesses. This is also not very easy to do. You have to think critically, but in general, the papers don't, of course, advertise their weaknesses. They usually advertise a lot what they achieve in their contributions, but you have to think very critically to identify any shortcomings of the work. And of course, this doesn't mean that the paper and the work is not good. It just means that there is room for improvement. Also, some of the papers, for example, when they first identify a problem, this is an achievement on its own and it's something worth reporting. So it makes sense that after identifying a problem, you don't come up with the best way to solve it, right? So this is why there is room for improvement for the following papers to expand on it and give, let's say, more elaborate and more sophisticated solutions. So once we're done with the critique, you can move on to some thoughts you have and ideas on what you could do better and how it can be done better, and overall your takeaways of this paper. Then you can think of some discussion points to introduce with the audience so that you can engage them and start taking questions and then interacting with the audience. This is an example of an executive summary of a paper. This is done from a recent PhD graduate from Safari, Girai, and this is the executive summary of a paper he presented at the DSN conference. There are a lot of examples for you to see online, so that you can also stay close to this template when you're also making the summaries for your own presentations. Some other ones too. When you're presenting, we expect this sort of structure for your presentation. So as we said, identify the problem and the goal, the key ideas, the novelty, the mechanisms, and major results. This would be expected by you to be presented in around 15 and 20 minutes. And then we move on to the critical part, and which is the critique, right? Strengths, weaknesses, alternative solutions, some new ideas. It should be 10 minutes your own critique plus 20 minutes the discussion. So overall, it's around a 50-minute presentation for each of you. And you should try and make it, let's say, more lean into the critique and discussion. So make sure you don't go over time with the summary, so that we are able to encourage the discussion and some constructive discussion and fruitful sessions. So these are some additional advice on how to do good reviews. The most important takeaway is to be very critical and find better ways. You can even question the problem itself, as we said. And of course, come up with new ways on how to progress what is presented and give different and alternative solutions. A very important aspect that we wanted to make sure you know, and there are also like many material that you can study on this. It's very usual during when you review papers or like say seeing a presentation of papers that you get into some rat hole discussions. This means people fixating on some specific aspects that you can always harp on and pick up on that do not really lead to very constructive criticism, let's say. So these examples are the workload, the metrics, configuration, and other details. For example, anyone could say that, okay, this paper tackles this workload, but it doesn't tackle other workloads. And of course, there are a million of different workloads, so this is a never-ending discussion point. Typically, this is also done with metrics. Since computer architecture is very tightly integrated with the concept of doing something like very efficiently, people will say that, okay, you have achieved good performance results, but what about energy? And these are, of course, some valid points, but it's more constructive to acknowledge them and then move on to providing better solutions and solving the problems. So make sure you don't really let close your mind and only focus on these details, but rather acknowledge them and move on to doing some more constructive criticism. This is the book where this picture is taken from, and you're very welcome to study it. It has some really nice tips about how to do presentations, how to avoid such questions that lead to rat hole discussions, and also yourselves as part of the audience to not fixate on such issues. And then there is another talk. This is a former colleague of Professor Mutlu, where he presents and proposes some ideas to give good talks. So this could be applied both to giving talks as well as to writing papers. So let's see one by one of them. Every sentence matters, and the audience prefers not to think. This basically means that you have to be very mindful of the sentences and the words you're using, and you should be able to guide the audience into reaching the conclusion that you want them to reach. Do not let them wander off and thinking things that you actually don't want them to think, but rather guide them so that they can easily understand and follow your train of thought. Also, another nice rule is that surprises are bad. Basically, you don't want to surprise the audience with any new information. A typical example of that happens in papers where people just, for example, focus on giving too many details on a mechanism or the implementation of their work. But after the reader has gone through too many technical details, they still don't understand why you do the architecture. So make sure you first give some, let's say, context and let anyone understand why you're doing it so that they understand also the how later on. and understand the impact of your work. Make sure you explain figures, graphs, or equations that you use. And finally, when you receive some feedback, you should have the assumption that the audience is always right. So if they have not understood something, it's more likely that you have not communicated effectively. So just take into account their feedback and try to improve your talk. So I think we can have a break, and then we will continue with some more information. It's not going to take the whole 2 hours, but let's have our break now, and we'll continue when the bell rings. Thank you. Can you hear me? Good. Okay, so then let's continue a little bit. There's not many slides left now. So this is one of the slides that Professor Mutlu likes to show and usually asks people if they know whose painting this is. I'm going to just tell you that it's Salvador Dali's painting. Sorry. So this is one of his first paintings. And this is one of his most known paintings. And you can see, of course, the difference. And the takeaway from this allegory is basically that you have to first learn the basics before you can start consciously choosing to break them. And this is a nice, let's say, fitting analogy in terms of how you learn and you understand the background and the state of the artworks and the literature. And then you're able to do some critique on the papers and come up with new ideas and new solutions that maybe disrupt some of the existing notions, but also pushes forward the research. So in order for you to have some good presentations and do well in this course, we have some material for you to use as an example. So many seminar talks, ones that are done by previous students, starting from last spring semester and going back to the fall and other years. And of course, we include some presentations by people that are members of Safari and how they present their own papers in conferences or in the context of maybe some courses to students. You can check online. These are all included in the slides. We have uploaded them in the course page, so you can check them out and use them as a template in order for you to create your own nice presentations. So overall, to recap what we were discussing in the previous hour, in order to take the most out of this, you have to come prepared. You have to read the papers or at least skim through them if reading is not always possible. Critically evaluate them, think out of the box, think new ideas, bring some discussion points and questions, read other papers to help you come up with new ideas. Be critical and be very much present and engage in conversation and discussion during the presentations. Now, this is like an algorithm that we have prepared for you to understand how you need to organize yourself so that you do a good presentation. So first of all, once we assign the papers, you have to check very quickly which is your presentation date. And please do this very quickly so that you can let us know if there is a conflict in your schedule so that we can reschedule and make sure that we have sessions that always have two presenters, okay? Then you move on to studying your paper. Some advice and some, let's say, easy rule for you to approach this reading of the paper is to be very careful. So read the paper in detail, look up any terms you don't understand. Potentially you will have to look into other papers to understand the one assigned to you, and make sure to view it critically, find the limitations and the flaws that this paper might have. And last, be creative about it. So try to think of ways to improve it and suggest them and discuss them with the other presenters when it's your turn to present your paper. It also helps if the paper has some open source implementation. It could be beneficial for you to also try and run some examples by hand or use any online tools so that you are sure that you understand it in full detail and you're able to also answer any questions that your other colleagues might have. Of course, if there is some difficulty in understanding some concepts and some parts of the paper, you should consult your mentors and ask any questions you might have. Now, when you create the first draft of your presentation, you have to keep in mind all the things that we presented in the previous one. You have to explain the motivation. You have to clearly present the technical solution and results of the paper, however, without getting into too much details. And then you move on to outline the limitations or potential improvements that you see. So focus on the key aspects of the paper. Don't get too much into details that only will potentially make the audience more difficult to follow because they have not read the paper in the detail that you have, and they could be lost in the details. So make sure you present some nice high-level abstract view, but still they're able to understand the basic contributions and the basic key mechanisms of the paper you're presenting. Now, during your preparation, you have to meet your advisors, your mentors to get feedback, and you have to organize this very well into the semester and you schedule it on time. So once you know what the date of your presentation is, you should reach out to your mentor, contact them so that you can set up meetings with them. You should have at least 2 meetings. In the first one, make sure that you have sent their slides in advance. Actually, in both meetings, this would happen. So that he can also come prepared to the meeting, and schedule the 2 meetings well advance of your presentation so that you have time to address their feedback, and definitely address their feedback. They are very much experienced speakers. They have presented their papers in top conferences. Some of them have also, they're done with their PhDs. So make sure you trust them and let them help you improve your talk and give a nice talk to all of your other colleagues. Okay, now some details about the grading scheme we will utilize. So we will grade you 60% of your grade is the quality of your presentation. We will take into account things like how well you understood the material, how well you presented it, how well you answered the questions by your colleagues, if you were able and prepared to explain any technical details. Of course, we will take into account how difficult the paper was and if you have the proper time to prepare for it. Although this year we're trying, and I think we will achieve it, that you all have at least 2 weeks to prepare for your presentation. Then we're going to grade you on your final synthesis paper. This is going to be the 30% of your final grade. It has to do with how well you understand the papers presented, and you're going to answer questions about all the papers throughout the semester. Your attendance in the course, as well as the quizzes that you're going to fill one day, up until one day after its presentation, is taking 10%. And lastly, you're going to be awarded with some bonus points when you have a very active and creative, let's say, participation in the way the class is conducted. This means asking questions, thinking, and make sure you speak your mind when you have any ideas about the papers you see presented. Okay. Also, another thing that we might do if there is time is that we will also give you some feedback once you do the presentation. Of course, if you're not comfortable with this, make sure you let us know beforehand and we can skip this part of the session. And you can then, after your presentation, arrange a meeting with your mentor so that he can give you feedback on how well you integrated his comments, her comments, and basically build upon that to also be better in the future in making presentations, which is a very important aspect in whatever career path you choose, I think. So this is the expected schedule with some specific dates this time around. So we will meet weekly, once per week. Our next meeting is next week. There's going to be a lecture. And your presentations will start on October 9th. We're going to schedule 2 presentations per session. Each one will take around 50 minutes, including the discussion section that we mentioned before. The paper assignment is going to happen probably next week, as we said. We're going to upload the list of papers from which you will rank based on your interest and your preferences. And we will try to make an assignment as close as possible to your interests too. So please check Moodle, check your email, and be quick to respond to us about your availability when you see the dates that have been assigned to you. Now let's go on to talk about homework 0. As we said, it's going to be available today and it is due next week, September 25. Here you're going to provide some information about yourself. If it's not submitted on time, you cannot be scheduled for the presentation and it's like you're quitting the course. So please make sure to do this if you're interested. And now again, I want to stress out that please keep the course if you're really committed into putting the work. There is a lot of work in being able to make a nice critique of the paper, and also committing to attending all of the lectures and giving nice feedback and good discussion points to the other people that are trying and develop the research skills. So please be very mindful of that. And if you don't feel like your heart is in it, please, you can drop the course, find something that suits you better, and also allow people in the waiting list to participate. Next, the review and analyzing a paper. This is due on October 2nd. This is also mandatory, as we said. The paper review preferences, it says to be decided, but hopefully it will happen next week indeed. And the synthesis report, this will happen 1 month after the last presentation at the end of the semester, basically. And it's also mandatory, as we saw earlier. So please, I think we have discussed a lot about how to approach this course, and I think you now know that you need to be very open-minded, put in hard work, and do some nice critiques of papers. This is some of the feedback we got from other students that have taken the course. They characterize it as a formative experience. Like this is a skill that have really helped them and will help them into their future. High investment, as I said, it's a lot of work, but we also have high return. And other many comments, you can see them all at your own time. So please go through this material. I hope you like and you're excited about this new semester and the way the course is going to be done. Feel free to go through our website and go through all the material that we have available for you to expand on your knowledge and any other skills that you want to work on. So I think that with that, we can conclude this introductory lesson. I wish you a good semester and a good incarnation of this course. Okay. Thank you very much. Do you have any questions? Feel free to reach out to us, of course, in our emails.